Okay, so fortunately I did actually happen to have some 1/4 inch aluminium plate, so I cut a couple of pieces off and I've squared them up on the shoreline much the same way as we did with this piece. And these two, that one is exactly to the right size, that's ready to be marked up. This one is a little bit longer because the plans call for the ends to be rounded off, so this one is a little bit longer than the given dimension, which is 3.45 inches. That just allows me a little bit of on the end for rounding off. So I thought, right, well, what we'll do today with this is we'll do a bit of old school marking out, because I'm very lazy, so I do tend to mark out using the digital caliper, but I do actually have a surface plate and a height gauge, so we're going to use that today. So we'll go over there and we'll mark these out using the surface plate and the height gauge. Okay, so we're over on the surface plate and I've got the height gauge set to exactly 0.25 of an inch, which should be exactly half of the 1/2 inch piece of little aluminium plate I've got here. So we'll scribe that line, try and do this without getting in the way of the camera. And there you go, simple as that, job done. Now, because this is not of any, this is oversized, I need to find the center, and then I'm going to use dividers to mark off the two drilling points for the holes, because the crucial distance is it's the distance between the two holes. So we'll set that up next. Okay, so we're back over on the workbench. I've marked the center on this piece. Now, it's quite crucial that the centers, the distance between centers of these two holes is 2.926 inches. So half of that is 1.463 inches. So the idea is that I have set this to the dividers to half, exactly half. I put a little tiny center punch mark on here, if I can find it, which I can easily polish out later on. There we go, and then I can just do that. Oh, it's come out. Do that again. There we go. Move it around. Do the other one. So hopefully, when I measure that, that should be exactly 2.926 between centers. And now we've got those holes, we can drill those out on the shoreline. Okay, so I've got the piece in the vise on some parallels. We've got a 4mm spot drill in here, and we've got it centered up on the mark on the work. So I'm going to spot drill that, and then we'll put the 6mm drill in, which is ideal for reaming to 1/4, and we'll drill that 6mm after this. Okay, that's our spot drill done. Right, 6mm drills in. Yeah, I think I must check my belt tension on the mill. It's definitely slipping. We shouldn't have any trouble with this. I'm going to change out the drill bit. I think that drill bit must be really blunt, because it shouldn't really have any trouble drilling through this at all. Right, we've got a brand new drill bit in there now. Right, we've got the reamer in there now, so we're going to ring this 1/4 inch. I'm going to slow the mill right down, obviously, to do this. Right, so that's one done. I'll swap it around and do the other one. Okay, this piece is pretty much finished. I've got to round the ends off. I think I can hopefully mount this on my little tiny rotary table to do the ends. I mean, you could do them on a disc sander or a belt sander. You know, you could do it that way, but you get a much nicer finish if you do it on the lathe. The problem I was having drilling the hole turned out to be the belt was slipping on the Sherline. I'm not really surprised. I've been using it an awful lot just lately, so it just I don't like to run the belts tight. They are on the Sherline, they are basically, well, the belt is only really a sewing machine belt, so I don't like running them too tight. So yeah, it just needed a little bit of tweaking, and the second hole it just drilled through that, no problem at all. So that's pretty much done. So apart from rounding off the end, so now we need to mark this one up, which is slightly more complex because it has two holes, one which is on the center line, which is 1/4 inch, and then one which is in a slightly different position, and it's only 1/4 inch from the end, and that's one which is drilled and tapped for 832 UNC. So we'll take that one over to the marking up table and get that done. I thought we'd try a bit of a different technique for rounding the ends off of this piece. I saw Craig Tate use this on his YouTube channel to quite a good effect. It's a very simple method, providing your bit of bar that you want to round the ends off of has actually got a couple of holes, or a hole in the end you want to round off, and of course ours has. So what I've got here is this is a piece of 1/4 inch steel stock, which is lined up in the x-axis. It's perfectly in line with the spindle, and these washers basically are used to space the piece you want to actually work on away from the device jaws. So we're going to flip that onto there, so I can move that like that in this plane, and the idea is that we wind the cutter down like that. The cutter stays fixed, and we use the x-axis thread here to move this into the cutter like that, and then we move the piece of work like that, and it will round it off. That's the theory. So we're going to try that today and see what actually happens. That seems to be working okay. I'm going to carry on with this, and I'll let you see it when it's finished. Well, that worked out to be quite a good method of putting a radius, quick and dirty method of putting a radius on the end of a bar. I polished them up on the disc sander to clean them up, but apart from final polishing, our conrod is done, and I'm quite pleased about the way that came out. So the next thing is to move on to the main crank, which is, or the main crank lever I should say, which is this one. So the first thing we've got to do is spot those two holes that I've marked out there on the on surface plate.